All right, everybody, welcome to Math with Grace. Today we're going to be looking through Relations and Functions, or 12th grade math, book 1202, sections 1 and 2. Section 1 begins on page 2, and we're talking about linear functions. This is a bit of a review. And in a linear equation or a linear function, it's to the first degree, and it's usually in this form, y equals mx plus b. When I say first degree, I mean there's no exponent anywhere, okay? This represents a line. But they want you to note that a vertical line is not a linear function, because remember, if our line is vertical, then we have multiple y parts or ranges for every one, because we only have then one domain, right? We can't have that. That's not a function. So a vertical line is not a function. You guys know a lot about lines. You guys know a lot about graphing lines here. They took a simple line and they found points, but we don't have to graph it that way. We know that this plus 2 is where we start on our y-axis. And then we have a negative slope of 1. So we go down 1 over 1, down 1 over 1. Okay, now if you want to do points, and trust me, in many of, if not all of the problems up ahead, we're going to have to do points because they're not going to be this simple. That's fine. But if you can just graph this the normal way, that's great too. Now, the top of page 3, we get to read about a zero function is a value of x for which y becomes 0. Now, sometimes we're lucky, and that's when x is 0, y is 0, right? But that's not always the case. So in this example here on the page, the 0 function is actually 3, 0, because this is when our y is 0. So 3 is the 0 function, okay? And it says here that the 0 function is the x-intercept, where it crosses the x-axis. All right, and that's the case, right? At 3, 0 is where we cross. Now, a special case that we have to consider is something that's represented like this, right? We know that we have a fraction here and that we have an exclusion. Our x cannot equal -3. Therefore, we graph this like normal. They factored and then found some points, right? But when they graphed it, they had to make a hole in it. And they have to make a hole because x cannot equal -3. So even though the line passes through that point, there's actually a hole. And if you've taken geometry, you know that lines don't have holes. So we got a ray going this way and a ray going that way, right? But we have a hole because x cannot equal -3. Let's turn the page. So at the top of page 4, they want us to graph the following functions. So for number 1.1, we are to graph f of x is equal to x plus 3. I'm just going to set up, apparently it's super sloppy, but just a basic graph here in the middle, okay? Now, we know that this plus 3 is our b in our y equals mx plus b situation, right? And that's where we cross the y-axis. So we're going to count up 3, 1, 2, 3, and put a dot. Then we looked for our m, which is our slope. Well, it's 1, so we know we're going to go up 1 over 1, up 1 over 1. We can go back 1, down 1, back 1 as well. Now, through the magic of editing, you did not have to watch me scramble for 10 minutes to find my ruler, but I found my ruler. And I can draw in our line. Okay, simple enough, right? Very basic, very much what we've done before. Now, 1.3 is a little bit different. They want us to graph the inverse of f of x equals x plus 3. So we have to solve for the inverse. Now, remember when we solve for an inverse, we're just switching the x and the y. So it becomes x is equal to y plus 3, all right? And then we solve for y. Y is equal to x minus 3, right? I just subtracted 3 from both sides and I just switched it around, which I like my y on the left, okay? So that is what we're going to graph. Now, again, we still have our b. So let's put in our lines here. And in this case, our b here is a -3. 1, 2, 3, we put a mark. Our slope is still a positive slope, so we're still going up 1 over 1. Grab my ruler and draw in my line. Okay, so we're going to graph some more. Let's take a look at page 5. I've got a couple problems I'd like to do over there. So on page 5, I'd like to look at problem number 6. Now, here is the problem we were just talking about that has to have an exclusion, right? The denominator is 3x plus 5. So we set 3x plus 5 equal to 0, and we solve for x. And we see that x cannot equal -5/3. Okay? That right away is going to be our hole. Okay? The hole in our line. But now we have to solve this, reduce it, and then we can graph it. So 9x squared minus 25 can be factored into 3x plus 5 and 3x minus 5 all over 3x plus 5, right? These cancel, and so we're left with this 3x minus 5. So that's going to be our graph. Because we're doing minus 5, I'm going to move my x-axis way up here so I have room to get to -5. So the -5 is our b, right? 1, 2, 3, 4, 5 down, and we put a point. 3 is our slope. So we're going to go up 3, 1, 2, 3 over 1. Up 3, 1, 2, 3 over 1. Now, where does our hole need to be? Well, our hole is at -5/3. And if you go into your calculator and you put in 5 divided by 3, you see that it's 1.666, negative. So when x is 1.666, which is going to be, because it's going to be down here somewhere, right? We have to put a hole. So let's draw our line. My ruler's getting a little rough on the edges here. And then we're going to have to estimate where 1.566 is. It's like somewhere around here. And we're going to put a hole. Okay? And so that's it. We have to figure out what is our exclusion. Then we could factor this one, factor it easy enough, graph what we were left over, make sure we put our hole. Okay? All right, let's move on to the next topic. All right, the next topic that started on page 5, I'm looking at page 6 though, is about equations. And the first bit of information they give you is the slope formula. Okay? So we've used the slope formula lots of times. It's the change in y, which is what's represented here, the change in y over the change in x, or y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Definitely something we've done before, finding the slope of the line, okay? The next example that they're talking about is our 2-point form. Okay, this is at the top of page 7. This is the 2-point form. If we know 2 points, we can put them into our 2-point form. Okay, and this is the basic setup of the 2-point form. Now, they put the slope formula in here, which to me makes it look pretty messy. So I rewrote it, probably something you're more familiar with. Okay, this is the slope point. They're calling it the 2-point form. In the past, we've called it the slope point form. M representing our slope. Okay, if we have 2 points, we can put in our point. Okay, we can solve for our slope and put in one of the points to solve for our line. All right, review, we've done that before. And then they move from that right to the slope point form. It's the same, pretty much the same thing, except here you needed 2 points because you needed to be able to find the slope. Down here, for the actual point slope form, they're giving us 1 point and the slope. Okay, so we already have the slope and they're giving us 1 point. For this 2-point form, which I rewrote, but the 2-point form, that you have to have 2 points so that you can find the slope and then find the equation of the line. All right, so make note of these formulas. They're all ones we've used before. And let's turn the page. All right, so taking a look at page 8, we're reminded of the slope-intercept form, which looks like this: y equals mx plus b. We just dealt with that when we were graphing just a minute ago, right? And so to find the equation of a line with a slope of 3/4 and a y-intercept of -2, we simply know that our slope is 3/4 and our b is -2. So our line must be y equals 3/4 x minus 2. And they've wrote it in this form, but that's not the slope-intercept form. So we're not going to worry about that. But as you scroll down and they continue to manipulate this equation, I just want you to notice this equation here. I don't know that it has a name. They've not named it. But when we move over here, we will take advantage of this version, okay? Now, they're going from this version, and as they're working through here, right, here's the 2-point form that they had, and they're working through, and they end up over here with our intercept form on the top of page 9. All right, where x over a plus y over b equals 1. Okay, this is called the intercept form. And this is a form where it says, can this form be used with a line that passes through the origin point? No, it cannot, okay? Because since such a line, both a and b would be 0. That's not going to work. So, something useful it says that we can pull out of this, though, is this midpoint form. And our midpoint of x is a plus 0 over 2. And our midpoint for y would be 0 plus b over 2. All right, so we have to know what the midpoint is. Since we haven't really done a problem like this, so to speak, let's take a look at this example. And it says, this point 3, 2 bisects a portion of a line that is cut off by the coordinate axis. So here's the portion of the line and it's cut off by the axis lines, and 3, 2 is the midpoint of the section that's left. What is the equation of the line? Well, we will see here that 3 is equal to a plus 0 over 2, right? And 2 is equal to 0 plus b over 2. Simply, you just put in our point here into this equation. And then we solve for a and we solve for b. And they get a equals 6 and b equals 4, okay? Perfect. That's exactly what we wanted to know, right? But here's the thing. It goes on to the next page. It puts this information back up here into this equation and then solves. But really, that's a step we don't need to take. If we know our a and our b, then we can just put it in right here, okay? So y is going to equal negative b over a, or 4 over 6, okay, times x minus a, or minus 6. So setting it into this equation, now let's solve this out. Y is going to equal negative 4 over 6, or we can reduce that. Let's go ahead and do it to 2/3, right? X. And then negative 4 6 times negative 6, our 6's cancel, the negatives cancel, and we're left with plus 4. All right, that's much easier. We'll turn the page and look real quick, but it's much easier than putting all the information into here and then solving for y. This little short halfway step was much better. That's why I highlighted it. Now, if we can turn the page, and they have actually a box with a summary of review, all the formulas that we just looked at. So you can see here at the top of page 10, they put the a and the b in, like I said, and then multiplied, then moved things and divided, and they came up with the same thing we did. More steps. I feel like using that other little chunk of formula is probably a better place to start. Now, feel free to write that one in here into this box if you like, since this box has a summary of all the different things that we talked about. Like I said, I don't think it has a name because it's kind of just a halfway point from here to here, but it was very useful at the same time. Okay, let's take a look at some of these problems. All right, so we're in book 1202, section 1, page 11. First problem I want to look at here is problem number 12, and it asks us to find the slope of a line through those 2 points. So we want to use our slope formula, right? How do we find the slope? Now, it isn't written in that summary box, but it probably should be. But remember that our slope is the change in y over the change in x. So that being said, we're going to take y2 sub 2, right? We could label them x sub 1, y sub 1, x sub 2, y sub 2. So we take our y sub 2 minus our y sub 1 over our x sub 2 minus our x sub 1. Now I put this one in parentheses because I don't want to miss the fact that we have a minus minus, and minus minuses must be changed to plus. So we have 3 plus 3, which is 6, over negative 4 minus 2, which is a negative 6. So our slope is negative 1. Okay, they asked us to find our slope. Our slope is negative 1. Now for number 14, they want us to write the equation of the line satisfying the given conditions. For number 14, we're given the slope and we're given 1 point. So we are going to use the point slope formula to solve for our equation. Our point slope formula is y minus y sub 1 is equal to m times x minus x sub 1, where the y sub 1 and the x sub 1 represent the point, and the other x and y, they just stay there. So I've got y minus 3 is equal to m being the slope, or negative 4, times x minus and negative 2. All right. Y minus 3 is equal to, we have our negative 4 here, but we've got a minus minus. We can't have a minus minus. We make that a plus. Negative 4 times x is negative 4x. Negative 4 times a positive 2 now gives us a negative 8. Okay. We add our 3 to both sides, and we get y is equal to negative 4x minus 5. All right, that is the equation for our line. Now, for number 18, it asks us to use the equation that we found in number 14, but change it over to the intercept form. The intercept form is x over a plus y over b equals 1. Now, to find our a and our b, we have to figure out where it intersects the axes, right? So if x is 0, what is y? Well, if x is 0 here, we have to solve and figure out what our y would be in this equation. If x is 0, our y is going to be negative 5, right? 0 comma negative 5. So that is what our b is. Our b is negative 5. But what if y were 0? How would we work that out? Well, if y is 0, then we have 0 equals negative 4x minus 5. And we solve for x. I'm going to move my 4x to this side by adding 4x to both sides. So 4x is equal to negative 5. X is equal to negative 5/4. Okay, this is my a. Now I can write my equation. I found my b, I found my a. So the equation written in intercept form is going to be x over negative 5/4 plus y over negative 5 equals 1. Okay, that's how we solve for our a and our b to put it into this form. Let's take a look at our next topic. All right, our next topic starts at the bottom of page 11, and it's linear inequalities. And they have the form of ax plus by plus c is either greater than or equal to, less than or equal to 0, or some other constant for that matter. And these are called linear inequalities. Okay, every line in a plane divides the plane into 2 regions, one on each side of the line. Okay, so here's the line. It's divided into 2 planes the plane is divided into 2 regions by that line, and they call them half planes, right? Here's this half of this plane, here's the other half of that plane. Let's turn the page. We've all graphed inequalities before, but let's take a look at this one. They want us to graph the inequality x minus 2y plus 8 is greater than 0. We solve for y, and we find that y is less than x over 2 plus 4, okay? to graph this, we graph it like it's an equal sign to start, right? And we find our points, we figure out where they need to go. Basically, this is the same as y is equal to 1/2 x plus 4. So we know we're starting at plus 4, and our slope is up 1/2. All right, but because technically it's less than sign, it's not an equal to, we know that our line has to be a dotted line, right? Then the question is, where do we shade it? Okay, and it's going into a bunch of information here, but we need to just remember what we've learned. Less than, we shade underneath. Greater than, we shade above. You can always feel free to pick a point. Here, I would suggest picking the point 0, 0. Does it fall and satisfy this equation? Is y less than 0 divided by 2, which is 0 plus 4. So is y less than 4? Yes. Okay, so we shade underneath. Done. All right, let's turn the page. Sometimes we graph more than one line in a coordinate plane, and we need to make sure that we're only shading the region that satisfies all of them, okay? But let's take a look at problem number 22. Let's start there. Y is greater than 3x minus 1. All right, so we're going to go ahead and graph this as if it was an equal sign, at least to start with, you know, to find our points. And our first point is this -1. So here's our dot. That's where we cross the y-axis. Our slope is 3. So we're going to go up 3 over 1. 1, 2, 3 over 1. Okay, that's our line. Now, because it's greater than, we have to put in a dotted line, though. Okay? It is not equal to, so it does not get a solid line. It is greater than. Now, because it's greater than, our shaded side should be on top. But let's check it, because if we look here, again, our 0, 0 isn't quite on the line, so we can use that as a checkpoint. Is 0 greater than 3 times 0, which is 0? So is 0 greater than -1? Yes. So we are confirmed that this is the side that we shade. You can shade it how you please. You can fill in every single speck of space to shade it, or you can just do what I did. As long as I know where you're shading, that's all that matters. Let's look at 23. Here we have 9x plus 3y minus 7 is greater than 0. We want to solve for y. So we see that 3y is greater than or equal to -9x plus 7, right? We got to divide the whole thing by 3 because our y has to be by itself. So y is going to be greater than or equal to -3x, because 9 divided by 3 is 3, plus 7/3, which I hate, okay? I really, truly hate. But it is what it is. We're going to graph it and see what we got.
So setting up our graph, let's see here. I'm trying to think while I'm setting this up what exactly 7/3 is going to look like. It's basically 2 1/3, right? Ah, man, I hate that. If I do 1, 2, 3, 1, 2, 3, that gets me to 2, but it doesn't get me to 2 1/3. Just trying to figure out the best way to graph it, because we want to make sure when we're moving by our 3 points that we're moving in a good, even space.
So what I've decided to do is move my x-axis down. And so I'm going to move it down to here, which should give me enough room for each of these to be worth 1/3. Okay, so 1/3, 2/3, 3/3. So that's my 1 mark, right? So 1, 2, 3 would be my 2 mark. And 7/3 would be 1, 2, 3, 4, 5, 6, 7, which would be right here. Okay, you can mark it this way, but I need to be able to see what you're talking about. That's why I put this little 1/3 over here, okay? Label your graph and we're set to go. Now, my slope is -3. So it's -3 over 1 or down 3 over 1. So when I'm going down 3, I got to make sure I go down actually 3. And to do that, every one space is 3 blocks because I made them 1/3. So if I go 1, 2, 3, that's 1. 1, 2, 3 is 2. 1, 2, 3 is 3. And then I need to go over 1. 1, 2, 3. Okay. Technically that's 1 because each of these blocks are 1/3. It's a 1/3 by 1/3 now. Might be a little confusing. Feel free to estimate. I like to have my points on point. That's just the nerd in me. All right, so because it's greater than or equal to, we can actually have a solid line here. Okay. And then we need to decide, where do we shade? Again, the origin point is always my favorite way to check. It's greater than, so we should have to shade over here, but let's put in the origin and see. Is 0 greater than or equal to, this becomes a 0. Is 0 greater than or equal to 7/3? No, it is not. So, like I said, greater than is on top of the line, less than is under. So this is the side that we would shade. All right, I want to take a look at one more problem on the next page. So this problem that I want to look at here is problem 29. And for problem 29, we have 3 lines. And I labeled them 1, 2, 3. That's what those little, in case it doesn't show up clearly on the video, it just has a little 1, a little 2, a little 3. So that as I graph these, I'm careful to make sure I have exactly what I need. Now, this one right here does not need to be changed in any way for it to be graphed. Unfortunately, 11 is a very big number, and this grid is not big enough to hold that. So no matter what I do, I'm going to have to make these blocks worth more than 1, okay? And I will probably have them be worth 2 points. But let's take a look at what we get here and what we have, and we'll see. All right, so taking a look at these, I'm going to just make my graph here. But I'm going to drop my x-axis a little bit lower than halfway. And each of my blocks is going to be worth 2 points, okay? So I can graph this one right off the bat. My B is 11, so 2, 4, 6, 8, 10, 11 is going to be halfway. Again, it's not ideal, but it's the best we're going to be able to pull out with this one because these are number 1 and number 2, they're a little on the squirrely side. My slope then is the -6 or -6 over 1, down 6 over 1. So down 6, 1, 2, 3, 4, 5, 6 over 1. Hits it like right here. I'm going to do one more point just to be certain. 1, 2, 3, 4, 5, 6 over 1 is like right there. Okay. And my ruler. Again, 5 minutes looking for my ruler, which was literally sitting like right here. See how it kind of blends in? All right. My ruler tells me that, and it's greater than, so I want a dotty line. Dotty, 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 dotty up, dotty down. And so there is that line. Now, the question is, let me put that right there where I can see it. What side of the equation or what side of the line are we going to be shading? Now, because we have 3 of them, I don't want to shade. You can shade them all in, but make sure once you've got all 3 that it is extremely clear where the actual problem should be shaded. But this is what I like to do because otherwise the shading gets to be too much and it starts to confuse me. I like to draw an arrow to what side I would be shading. Because it's greater than, I would be shading that side of the line. And that's what I like to do because too much shading, I start to get confused. But now let's take a look at equation number 1. And I'll just put it 1 right here, okay? Equation number 1 is x minus 2y minus 4 is less than 0. So we need to solve for y. We're going to do that by adding y to both sides, but then I'm going to switch the equation around. So it's 2y is greater than, see if it was over here, the y would be greater than. And then it's just x minus 4, right? We divide by 2 across the board. We have y is greater than 1/2 x minus 2. Okay, now this one is ready to be graphed. Remembering that our blocks are now 2 points tall each, we want to start at -2, which is going to be right here. Okay. And our slope is up 1 over 2. So up 1 over 2. Up 1 over 2. Okay. Get out my ruler. This is a dotty line again. So we want to make sure we've got our line all nice and dotty. And I usually like to extend it to the outer edge of the coordinate plane just so we don't lose it inside of everything else. But what side do we need to shade? It's greater than, so we're going to be shading the top. Okay, this part up here. Now, if that were it for, we were just doing 2 lines, the shading part would be this part here, right? It would all be this part, because that's the part that they have in common. But we've got this line number 3 here. And it is 4x plus 5y is less than 29. Now we've got to solve this thing for y, and it is not going to be clean. So rather than graphing from what we have, we are going to put in points and solve it that way. But first, let's solve for y. 5y is going to be less than negative 4x plus 29. And so y is less than negative 4/5 x, which isn't that bad. But then it's plus 29/5. Oh, that's where it starts to get ugly, right? So instead of working with 29/5, which is almost 6, but not quite, right? We're going to just find points. All right, so we make our little chart, and we are going to find our points. Now, when x is 0, right, this becomes 0. Y is 29/5. That does not help us at all. But let's see if there is something that can help us. 5 does not go into 29 evenly, right? But if we take 4 away, then it's 25, and 25 divided by 5 is an even number. So how can we get this to keep its identity? We multiply it by 1. So when x is 1, we have negative 4/5 plus 29/5, right? Which is 25/5 or 5. Okay. Now let's think of another way we can do this. If x were 2, this would be 8/5. That would make that 21. That's not going to help. If x was 3, that would be 12. And then we would have what? 17. That's not going to help. If this were a 4, this would be a 16. It would still be a 13. That's not going to help. 5 would make it a 20, but that's 29 minus 20 is 9/5. That's not going to help us. If x were 6, 6 times 4 is 24. Now we're dealing. Now we're talking. Okay, so 6 times 4 is 24. So then we've got negative 24/5 plus 29/5, right? And that's going to give us what? 5/5 or a 1. That is enough points for us to graph this, okay? Remember, 2 points make up a line. So we have the point 1, 5. So remember, every point here is 2. So we're going to go to the right 1 and up 5. 1, 2, 3, 4, 5. So right here shares a point with that line. And the other point is 6, 1. So 2, 4, 6, and then up 1, which is right about here. It is a less than symbol, so it's going to be a dotted line. And you can see already that it's made this triangle. 9 times out of 10, if it makes a triangle, we're probably shading the inside of the triangle, but let's just double check. Our y is less than, okay, so we're going to shade the underside of the line. So where do all 3 things have in common? Of course, like I predicted, some things can be predictable even in math. We are shading the inside of the triangle. This area is the only area that satisfies all 3 of these equations, okay? All 3 of these inequalities are satisfied by this area alone. All right, that takes you to your self-test. Go ahead and work through that and then come back to me and we will start section 2. Section 2 begins on page 18, and now we're talking about second-degree functions. And it says that this type of second-degree function is called a quadratic function. It's in this form. Y, or f of x, equals ax squared plus bx plus c. All right, it says that graphing of these involve curves, and they're a little bit more difficult to graph. So previously we discussed the zeros of a linear function, right? These zeros were the solution to the linear equation ax plus b equals 0, or the value of x, which makes the whole thing equal to 0, right? Now, to graph these equations, the easiest part is to find the value of x where they cross the x-axis, all right? That's where we know it crosses the axis. It's easy to graph. There's two methods we can use to find these zeros, and it's either factoring or using the quadratic formula. The factoring method we've done lots of times in the past, okay? Solve this quadratic equation by factoring, right? We use our check and guess estimate thing to say, what are our factors of 10? Well, one set of factors of 10 is 5 and 2. We work them out so that they equal this -7. So when this gets distributed back out, we come right back to where we began, okay? We've done a lot of factoring. We might be out of practice, but it isn't something that we can't pick up again. Moving on to page 19, we have the quadratic formula. Here's our quadratic formula. You may remember, x equals -b plus or minus the square root of b squared minus 4ac all over 2a. Don't forget your 2a. So solving using the quadratic equation will give us two real roots. Okay, and remember, this is our standard. So here's our a, comes before the x squared, the b comes before the x, and the c is the constant, which fills in this area. If you're missing one, it's just a 0, okay? So here they want us to solve the quadratic equation. I'm just going to set up what is a, what is b, what is c, and then you guys can put it in, or you can see how they put it in. So in this case here, our a is 4, right? The a comes before the x squared. Our b is 5, and our c, remember, this is the way it has to be, equal to 0. So we have to move the 21 over, and so our c is actually a -21. All right, let's turn the page. So looking at page 20, I want to do the first two problems with you. And the first problem, 2.1, is 6x minus 5x equals 50. And they want us for these two problems to solve by factoring. First, we have to write this in the correct manner, right? 6x squared minus 5x, we have to move the 50 over. Minus 50 equals 0. Now the equation is set up in the correct form that we can factor it. So let's take a look at what we've got here. I usually like to start with the constant, and then I do the second degree term. So my constant here is 50. So what are the parts of 50 factors of 50 that we can use? Okay, well, there's 1 and 50, right? 2 and 25, 5 and 10. Those are our factors, the basic factors that we can use. 1 and 50, 2 and 25, 5 and 10. Now I'm going to try the 5 and 10 because these numbers here aren't very big. I'm going to try the 5 and 10 and see if that works out. So I'm going to put a 5 here and a 10 there for now. Now, factoring our second degree term, it's 6x squared. There are a couple factors of 6, 1 and 6, 2 and 3. That's it, right? So I'm going to use the 2 and the 3. And for now, I'm going to put the 2 here and the 3 here. But what are our signs? Together here in the middle, we have to have a -5x. So one of these has to be negative and one has to be positive. Let's just try it like this first of all, because my 5x is a negative, so I'm giving my bigger number the negative sign. But here's the trial and error part. We have to figure out if this is right. 2x times 3x is my 6x squared, right? 2x times a -10x is a -20x. 5 times 3x is a +15x. And then 5 times a -10 is 50. Right off the bat, we got it on the first try, right? Because -20x plus 15x is -5x. So here are our factors. All right, solve by factoring, but we're not done yet. Now we have to take each set of factors and set it equal to 0. So 2x plus 5 equals 0, and 3x minus 10 equals 0. Here we have x is equal to -5 halves. And here we have x is equal to 10 thirds. All right, those are our factors that we found. Those are our roots that we found via factoring, okay? Trial and error, we just happened to nail it on the first try. Let's take a look at number 2. Number 2, we have 9x squared minus 16 equals 0. Here you can see we're missing our linear term, right? We're missing just the plain x. So that tells us that we have a sum and difference binomial here. It's probably been a while since you've heard that term. But a sum and difference binomial tells us that one is a positive and one is a negative, and they're going to cancel each other out. This is a perfect square root. This is a perfect square root, so that's what we're going to use. 3x and 3x and 4 and 4. Okay? 3x times 3x is 9x squared. 4 times a negative 4 is a negative 16. But what falls in the middle is this negative 12x and positive 12x, and they cancel each other out. So that's what its sum and difference binomial is. This one is a sum and difference, but it's not a binomial. This has 2 parts, this one has 3. That's where we get the difference here, okay? Now we need to solve. 3x plus 4 equals 0, and 3x minus 4 equals 0. So here we have x is equal to negative 4 thirds, and here we have x is equal to positive 4 thirds. And those are our roots for that problem. All right, let's take a look at a couple more. All right, so for these two problems here, problem 5 and problem 6, they want us to solve by using the quadratic formula. Remember, that is that x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2. Okay, that is our quadratic formula. So we need to identify our ABC. So for number 5, our a is equal to 2, our b is equal to 5, and our c is equal to negative 12. And then we simply put those numbers into our equation. So we have negative 5 plus or minus the square root of 5 squared minus 4 times 2 times negative 12 all over 2 times 2. All right, and now we simply solve. We have got negative 5 plus or minus the square root of 25 minus, or what? Or is this a plus? I've got a negative and a negative, so it's going to end up being a positive. 8 times 12 is 96. Right? All over 4. Which reduces again to my negative 5 plus or minus the square root of what's 25 plus 96? Well, that's 121 divided by 4. Now remember, we're looking for 2 answers here. So 121 is a perfect root, right? It's the square root of 121 is 11. So I have negative 5 plus 11 over 4. And I have negative 5 minus 11 over 4. These are my 2 answers. And I'm sorry, I'm using a little piece of paper. I'm trying to use up some scraps that I have. But I have negative 5 plus 11 is what? Well, that's going to be 6 over 4. We can reduce that to 3 over 2. There's one answer. Then I have negative 5 minus 11, which gives me a negative 16 divided by 4, or a negative 4. So sometimes, like the problem beforehand, we had 2 answers that were the same, but sometimes we have 2 answers that are very, very different, right? Like we have here. So let's take a look at number 6. We need to label our ABC. Our A is equal to 1, our B is equal to 1, and our C is equal to negative 1. Now we can put it into our equation and solve. So we have negative 1 plus or minus the square root of 1 squared minus 4 times 1 times negative 1. This one's super exciting. Over 2 times 1. So we've got negative 1 plus or minus the square root of 1 squared, which is 1. Negative 4 times negative 1 is a positive 4 all over 2. Okay? So we've got negative 1 plus or minus the square root of 5 over 2. Now, you could break it apart like we did here, but since we're not going to find a decimal for this square root of 5, this answer is sufficient on its own. It represents that we have two roots with this plus or minus. We just don't need to break them up. We can write them together like that. Okay? So you've got a couple more problems to do on your own, and then we have another new topic here on page 21. So on page 21, they're going to start talking about relationships between zeros and coefficients. Now, when it says zeros, what it means is the roots. It doesn't actually mean 0. It means those roots that we've been looking at, okay? And here they let R1, root 1, and root 2 be represented by R sub 1 and R sub 2. And then they broke apart the quadratic equation, right? The quadratic formula. Here with the positive, and here's one with the minus, right? Just like we did in the last problem. And basically what they found out is that if we write our equation like this, here's how it started out, right? Being a coefficient in front of our square, in front of our second degree term. But here they've rewritten it so our second degree term has a 1, right? But in front of it. If we can write it in this form, then the sum of the roots, okay, when we add our two roots together, is going to equal negative b over a. And we know, just by looking at this, our ABC, right? Negative b over a. And the product of the roots, and this is this part b right here, is going to be equal to c over a. Now, we talked about this a little bit last year, but let's take a look at what they're exactly talking about. Here at the bottom of page 21, they've done an example, and then the answer's on the next page, which I super hate, but here's what we got. They want you to write the quadratic equation in the form of this, basic form, right? Whose solution set, or their zeros, or their roots are negative 1/2 and negative 1/3. Well, here's what they did. We know that if we add them together, can I get it on here? If we add the roots together, it's going to be equal to negative b over a. So that's what they did here. And they did it right here, okay? We know if we multiply them together, it's going to be equal to c over a. And so they multiplied them here. Let's turn the page and see how they've completed this. So you can see here that they wrote that b over a is equal to 5/6, which we just solved on the last page, and c over a is equal to 1/6, which we solved on the last page. So then they put it back into that formula and worked backwards. But here's the thing. We can see then that a is 6, that b is 5, and that c is 1. So we can skip this step and just jump right to this step, okay? Because the form, remember, is ax squared plus bx plus c equals 0. So we can just jump right to here. I don't see the point in this step. And then having to multiply the whole thing by 6, multiply through by 6, that's stupid. We already have the answers right here. We just have to plug them in. All right? So that's how we work through that backwards. Now in this example here, they've given you the equation and one root, and they want you to solve for the other root. And so you simply have to put the one root that you're given into the equation here. They chose to use the plus one, which is fine. And then they solve for their other root, okay? That's impossible. They did it here too. And they solved for their root in the multiplication part. So here they got their b, and here they got their c. And so they were able to find the other root. Now, as we continue down page 22, we can see that they're continuing to talk about the quadratic formula, but now we're going to be talking about discriminant. And if you recall, the discriminant is what's underneath the radical sign here. The b squared minus 4ac is called the discriminant. The discriminant matters because it will tell us how many roots to expect. If our discriminant is less than 0, then our roots are imaginary numbers, okay? If the discriminant is equal to 0, then the roots are real and equal numbers. And if it is greater than 0, then the roots are real and not equal. Remember how we did one problem a minute ago where they had equal numbers, but then we did another problem and their numbers weren't the same, okay? So we also learn here that if the expression is a negative number, there are no real roots, which is what this says, right? Imaginary numbers. If it's equal to 0, then the function has 2 real roots. Okay, so it's not just the fact that there are real roots. We have 2 of them, and they're the exact same number. And if it's greater than 0, then the function has 2 real roots, but they're unequal. They're not going to be the same number, but they're still 2. Okay? And that's a representation of that. Let's take a look at page 23. And it says here at this example, without solving the equation, we want to determine the nature of the zeros of this equation. So to do that, the nature of the zeros, what kind of number are they going to be? We look at the discriminant. And our discriminant is 88. From what we just learned, it's greater than 0. So it's going to have 2 real number answers, 2 real number roots, but they're not going to be the same number. All right? Let's turn the page. So the top of page 4, we start talking about parabolas again. It's been a while since we've looked at parabolas, but parabolas, they're telling us, all have the same general shape. And it looks like this, right? This is the basic general shape. Here is an example of a parabola here on the bottom of page 24. Y equals x squared plus 6. Now we can find the discriminant, which tells us that the graph has no points on the x-axis. Okay, but what do? Well, we just put together a list of points, all right? So when x equals 0, y equals 6. When x is 1, y is 7. When x is negative 1, because negative 1 squared is a positive 1, our answer is 7, and so forth. And then that's what we use to graph, okay? Now, looking over here on page 25, we find out that if a sub 0, right, the first a, is less than 0, so here in our equation, basically the coefficient of our x squared, if it is less than 0, then our parabola is going to open down. All right? And one last note here before we turn the page is that when we have the polynomial written in this form here, y equals a times the quantity x minus h squared plus k, our hk is the vertex of our parabola, and x equals h becomes the axis of symmetry. Maybe this sounds familiar. Maybe it doesn't. But if we write this, so let's take a look at it. This equation in this form, what do we have? Well, we would have y is equal to negative 2 times x minus 0 squared, right? Because we don't have anything else there. So it's just technically minus 0 plus 0. So what is our h? Well, this is our h and this is our k. So our vertex is at the point 0, 0, which is totally true. All right. Now, obviously, this is a clunky way to write this, but it will help us to find our vertex when things get a little bit more complicated. All right. Let's turn the page. So at the top of page 26, they have another example of changing it over to the other form, right? Y equals x squared can be written as y equals the quantity x minus 0 squared plus 0. So we see that our vertex is at 0, 0, and our axis of symmetry is also at x equals 0. But we probably wouldn't necessarily do that with an equation that is that simple. But now let's take a look at an equation that isn't that simple. Y equals x squared plus 2x. Okay, we're missing our constant in this quadratic equation, right? So we have to complete the square, and it's been a while since we've done that, to satisfy this, okay? So what they did is they grouped together parts of it that they want to factor with, right? X squared plus 2x, but then they had to add a 1. They have to add a 1 to get this to be a perfect square set of factors, right? But since we added a 1, we also have to subtract a 1 because remember, we can't change the equation. So they added a 1, so they have to subtract a 1. So now our x squared plus 2x plus 1 becomes the quantity x plus 1 squared. and then here's our minus 1. So now we still have our h and our k, and so we find our vertex at negative 1, 1, and you're saying, but this is a positive, so why is this a negative? Well, remember that the general form is y is equal to x minus h squared plus k. So because this is a positive, then our h has to be a negative 1 for that to work out, right? Because it would be minus minus. All right, that's why that becomes a negative. Don't forget that. And then you can use either this equation, that equation, and solve for some points, because we still have to find points on this graph, right? We can't just leave it like that. I prefer to use this one. We set up our x and our y. We have our vertex, but that's not enough. We set up our x and our y, and the first thing I'd like to do is make this 0. Well, if this is a plus 1, to make it a 0, I would say x is a negative 1. So it becomes a 0, and my y is also negative 1. Boom, that's also our vertex. Okay, so that really doesn't help us because now we have the same point we already found. So we can't always use the same tricks that we're used to using going forward here. So let's take a look. That's our vertex. I like to go, let's try either side of it, because we know that's how a parabola works, right? It's going to go out on either side evenly. So let's try negative 2 and 0. They should have the same answer. So when x is negative 2, this becomes a negative 1. Negative 1 squared is a positive 1. Positive 1 minus 1 is 0. When x is 0, this is a positive 1. Positive 1 squared is positive 1. 1 minus 1 is 0. That's enough to draw our parabola. They've got another set of points up here, but I don't think that's necessary. Okay? So, complete the square. We found our vertex. We got to solve for a couple extra points so we could properly graph it. Sliding over to page 27, we see at the top of the page that it tells us that the vertex is either going to be the lowest or the highest point on the graph. Okay, so it's referred to as the maximum or the minimum value of the function. All right, but now they're talking about an inverse. Then they start talking about the inverse of a function. It's going to, or of a parabola, right? The quadratic function, but it's going to look different. So we need to notice that the inverse does not qualify as a function, right? If we move across here, there is more than one point for every, more than one range for every domain. So it is not a function. So they say you can use just the top portion here, because if you know the positive, you know the negative, right? Because they are a mirror image of itself. That's what this line of symmetry gives us. All right, so let's take a look at some of these problems. All right, on page 28 and 29, I'm going to do problem 9, 12, 15, and 16 with you. First, let's look at number 9. F of x is equal to 2x squared. Before we don't need to complete the square. We don't need to go that far. Well, let's just set up our x and our y and solve for some points, okay? If x is 0, y is 0, or f of x is equal to 0, right? Because 0 squared is 0, 2 times 0 is 0. Well, what about if x is 1? Well, if x is 1, 1 squared is 1, 1 times 2 is 2, so y is 2. Now, remember, I want to go out. We know this forms like a bowl shape. This is on one side of 0. Let's try a negative 1. Negative 1 squared is 1. 1 times 2 is 2. So they have the same point. So let's graph our parabola. I'm going to just draw in the basic lines here. And we have our 0, 0, our 1, 2, and our negative 1, 2. That is enough for us to get the general description of our parabola. All right, well, what about the next one? Number 12 is f of x equals x squared plus 4x. We don't have the constant. You could sit here and figure out problems, but what we really need to do for this one is complete the square and solve. So I've got x squared plus 4x plus something, okay? And then I have to add that same something on the outside. So what is going to finish up this to give me something that becomes a perfect square? A root that becomes a perfect square. Well, it's going to have to be something here, right? That gives me a 4x plus 4. That becomes a perfect root. But if I'm adding 4 here, I need to make sure I subtract it here. So now this becomes what? This becomes an x plus 2, right? The quantity squared. X squared gives me here, x times 2 is 2x, 2 times x is 4x, added together, 4x, and then 2 squared is 4, right? So we have to be able to think about how this factors down. We want a perfect square binomial. And our -4 just stays out there. So what is the vertex of this graph? Well, my vertex is going to be at -2, -4. Remember the standard form. Y equals the quantity x minus h squared plus k. Okay? This is the standard form. So for this to fit, I have to take the opposite. Now that's my vertex. I can chart that, and now I can throw down my x and y and find my other points. All right, this is going to be equal to f of x. So what are my other points? What other numbers can I use here? Well, my vertex is -2 and -2, 4, right? So I want to go to either side of that, which is going to be a -3 or a -1. So let's put it in here. -3 plus 2 is -1. -1 squared is +1. +1 minus 4 is 3. -1 plus 2 is a +1. +1 squared is still a +1. 1 minus 4 is 3. Right? You could find another set of numbers, but that's really enough. We're not looking to go crazy in depth here. So our vertex is at -2, -4. So -2, 1, 2, 3, 4, -4. The points that we have here are at -3, 3, and -1, 3. So this is a super skinny, tall one. Okay. But what we did was we found our vertex completing the square. And then we just used a point on either side of this x value to find the next point out, okay? So let's look at number 15. G of x is -x squared minus x. All right, so again, we're going to have to complete the square. So let's take a look and break this down. So we have G of x is equal to, and I'm going to pull the negative out, and that leaves me with an x squared plus x plus something, right? And then I have to add that something again, or do the opposite, subtract it. So what number here is going to make us be able to factor this into a perfect square? Well, whatever number it is, 2 of them have to equal 1x, right? Because that's what this is. 2 of these equals a 4. So what 2 numbers added together gives us 1? It's 1/2, right? 1/2 plus 1/2 gives us 1. All right, see how we're getting there? Let's take a look at it in the good old-fashioned style. This is a 1. We multiply that by 1/2, right? This is the old way that we learned how to complete the square. We multiply that by 1/2 and we get 1/2. We put that in a box. Then we take our 1/2 and we square it, right? And that gives us 1/4. So technically what goes in here is 1/4. When we break it down, it's going to be 1/2. Now here's where the rub comes in. We're not going to subtract 1/4 here. We added 1/4, but remember this negative out here. This negative has to be redistributed. So technically this is a -1/4. So we have to add 1/4. This is getting a little tight here. Let me see. So I have the quantity x squared plus x plus 1/4 plus 1/4. Okay, so now what is my perfect square here? That's where the box number comes in. It's going to be minus x plus 1/2, the quantity squared, plus 1/4. Okay, that's completing my square. Okay, so my vertex is at negative 1/2, 1/4. Right? That's where my vertex is. So now to find our points, let's go on either side of negative 1/2. Well, negative 1 or 0, right? Those are the biggest, closest ones. And we're going to put them into this equation. So negative 1 plus 1/2 gives me a negative 1/2. Negative 1/2 squared is a negative 1/4, but I've got this negative here, so it makes it a positive 1/4. That's not right. Well, it wasn't right because a negative 1/2 squared is going to be a positive 1/4, right? You square a negative, it becomes a positive, but then this makes it a negative again, so I have negative 1/4 plus 1/4, and it becomes a 0. Now let's put in our 0. 0 plus 1/2 is 1/2. 1/2 squared is 1/4. This becomes a negative 1/4 plus 1/4, and it becomes a 0. So crazy as that might be, we now have enough points to graph our line. Now, negative 1, 0, 0, 0. So I'm going to move my y-axis over a little bit here. And I am going to, let's see, because we need a negative 1/2, but a positive 1/4. So maybe like right here. And I'm going to label my grid as each piece being 1/4. Okay, so to get to a point on our x-axis that is a negative 1/2, it's actually going to be a negative 2/4, right? And then I go up 1/4. And then for my negative 1, it's going to be 4 chunks and 0. And my 0, 0 is right there. I guess I should have moved it up higher because this negative number here tells us that it's going to open down. So I didn't quite put my line at the right spot, but you still get the idea of what's happening, right? Here we have a negative. It's going to open down. This completing the square is definitely something we haven't done since last year, but it is something we've done before. Let's take a look and see. We probably have to do it again for this next one. So number 16, let's get it on screen here, is 3x squared plus 2x plus 1. All right, well, to finish this problem, we absolutely have to complete the square. And so I'm going to grab a sheet of scratch paper, and we will do that here off to the side. Let's see. All right, so we have h of x is equal to 3x squared minus 2x. I'm going to leave a space and write my plus 1 over here. I'm immediately going to put those in brackets because this is where I'm going to be completing the square. But the first thing I have to do is I have to get this to be a 1 coefficient. So I have to pull out that 3. So now I have 3 times x squared minus 2/3 x plus 1. Now I can complete my square. This has to have a coefficient of 1 for us to be able to complete the square. So to complete the square, we take this number, 2/3. We multiply it by 1/2, okay? 2/3 times 1/2 is 2/6. Okay, I'm going to put a box around it because that's how I like to do it. 2/6 squared is going to be equal to 4/36, right? And we can reduce that to 1/9. So now 1/9 is what I need to put in here, plus 1/9. All right. But when I put it out here, I can't subtract 1/9 because of this. So we have to distribute it. What is 3 times 1/9? 3 times 1/9 is 1/3. Since I added 1/9 here, 3 times 1/9 is 1/3, but I have to subtract it here. All right, so these become a little bit more complicated. Yes, we found our perfect square. Here's our perfect square now inside the parentheses. But because I have a coefficient sitting out here, I have to take that into play when I put my number over here. So what is my perfect root? It is 3 times x, right here, right? Minus. So it is minus, right? Because minus times minus gives us plus, but I'm about to write 1/3 because 2/6 reduced is 1/3. Okay, that's where I stumbled for a second there. All right, so this minus is here because we have a minus here. Even though here this is a plus 1/9, right? But remember, when we're getting this perfect square, we need to be able to work this back out to here. And to make this a minus is how we do that, because negative 1/3 times a negative 1/3 gives me a positive 1/9, right? So reduced our 2/6 to 1/3. And then out here we have 1 minus 1/3 or 2/3. So what is our vertex? Well, our vertex is negative 1/3, or sorry, positive 1/3, because remember our basic equation, sorry, I'm stumbling over myself today a lot, is x minus h plus k, okay? Quantity squared. Negative, so that's it. So our h is just that positive 1/3, and our k is 2/3. Okay, this is our vertex. That being said, now we know where our vertex is. Let's see if we can find some points to help us graph this graph, right? Well, our vertex x point here is at 1/3. So what are some points on either side of that that can help us? Well, first, let's look at our 0. And I'm going to write it out here. I'm going to kind of scooch my paper over so that we can get enough of this, as much of this as possible here to work with, because this problem is kind of messy and I like to just talk it out, but I want to make sure you guys can see it. So 0 gives us 3 times 0 minus 1/3, the quantity squared, plus 2/3, right? Well, this is just becomes 1/3. 0 minus 1/3 is a negative 1/3. Negative 1/3 squared becomes 1/9. So now I have 3 times 1/9 plus 2/3. All right. 3 times 1/9 can be reduced to just 1/3. So now we have 1/3 plus 2/3 or 1. All right. Kind of complicated, but 1 is our answer. So that was on one side of this 1/3. Let's go to the other side and try 1. All right, 1 put into here. 3 times 1 minus 1/3, the quantity squared, plus 2/3. What does that give us? Well, 1 minus 1/3, so basically 3/3 minus 1/3 gives me 2/3. 2/3 squared is 4/9. So I have 3 times 4/9 plus 2/3. This again can be reduced. So now we have 4/3 plus 2/3, which gives me 6/3 or 2. So these problems are kind of crazy, but if we can work through them carefully, we can see that they're not too bad. So we have our vertex, which is at 1/3, 2/3. And then we have our point 0, 1 and 0, 2. All of these are positive, so I'm going to drop my x-axis way down low, and I'm going to have my blocks all be 1/3. All right, so my vertex is at 1/3, 2/3. So here's 1/3 and here's 2/3. There's my vertex. Now my next point is at 0, 1, which is here. 3 chunks makes a 1. And then I have 1, 2. So I have an x is 1 And my point is, so the 1 is here, 1, 2, 3. And 2 points up is going to be actually 6 blocks. 1, 2, 3, 4, 5, 6. So you can see that these did not work out evenly, but that is okay. It's still enough points for us to finish, to draw in our parabola. Okay? We didn't have to find equal points. We just had to find some points so we could draw our parabola. All right? So remember when you're completing the square, okay, we take our linear coefficient, which is the x coefficient, we times it by 1/2. That gives us our 2/6. In this case, we reduced it to 1/3. I put it in a box because it's the number that goes in here. But then we have to square it, and we got our 1/9, and that's the number that goes in up here. And that's the one that we have to use opposites of. All right? We had to times it by 3, and that's how we got a negative. Here we added a positive, and then we have to subtract that same value. Okay? Then we can rewrite it like this, using the number we had in our box. And then we added 1 minus 1/3 to get our 2/3. All right, we'll be a lot more completing the square as we go forward. So don't get frustrated. If you have questions, let me know. Okay? Good job. All right, so our next topic is on page 30. And this is quadratic inequalities, right? We just graphed linear inequalities, but of course there's always quadratic inequalities as well. And so first we have to locate the graph relation, okay? So basically we have to graph it as if it were an equal sign, like this. And then we have to find the point either on the inside or the outside that satisfies the inequality. There is a trick to this one, just like there's a trick to the line one. And the trick is this. Less than or less than and equal to is on the outside. Greater than or greater than and equal to is on the inside. And what that means is this equation here is y is less than or equal to x squared plus 2, right? So we shaded the outside, okay? If it was greater than, then we would have shaded the inside, all right? That's the trick to these, right? It has a trick just like the other ones. Let's turn the page. Your test here is in the middle. Let's turn past that. And past that on page 31 is another example, and we aren't doing it. Okay, here is where it's our x squared minus 2x minus 3 is less than or equal to or whatever, 0. Well, here's the thing. There's no y there. So you have to graph the equation like there is a y, but then you take the y out, and it's whether or not you're on the line or on the outside. Or I don't care about those problems. We're not going to do those. We're not doing this section of it. Okay, if we turn the page, you can see what the answer would look like. So looking at the top of page 32, you can see that the answer would look something like that. We're not doing those. Okay, that's just too much. We're skipping that part. Don't worry about it. We'll cross off. I'll tell you which ones to cross off here going forward. But let's take a look right now at problem 219, something we can solve. Okay, graph the following relation. Y is greater than x squared. We don't have to go crazy. We don't have to square or solve by squaring or whatever. Let's just do it easy. If y is 0 or x is 0, then y is 0. Okay, 0 squared is 0. What about when x is 1 or a negative 1? Well, when x is 1 or a negative 1, then y is 1. Right? Negative 1 squared is 1. Positive 1 squared is 1. And same goes for 2 and negative 2, right? 2 or negative 2 squared is 4. Now, we don't need to do that many points, but let's take a look here. If we put in our graph and I drop my x-axis down a little bit, our vertex is at 0, 0. Then we have positive 1, 1 and negative 1, 1. And we could put in the other point too. Positive 2, 4, 1, 2, 3, 4, and negative 2, 4. Drawing our parabola. But the question is, It's not y is equal to, right? It's y is greater than. So if y is greater than, where do we shade it? Well, if it's greater, we shade it on the inside. Okay? It gets shaded on the inside. Less than is on the outside. So problem 22 gives us 2x squared minus 5x. I'm going to leave a space and have my plus 1, right? I need to fill in right here. But I can't complete the square until I remove this 2. I need a coefficient of 1. So it gives me 2 times the quantity x squared minus 5 halves x plus something plus 1 minus something. Let's figure out what that something is. I take my 5 halves and I times it by 1/2. Okay, that's going to give me 5/4, putting it in a box. Then I take my 5/4 and I square it. And that's going to give me 25/16. So my 25/16 go in here, but before I can put my number out here, I'm not going to subtract 25/16 because of this coefficient. Remember, let's not forget that we have to distribute this in. So what is 2 times 25/16? Well, they reduce, right? So it becomes 25/8. All right, it becomes 25/8. That's what we subtract over here. Now they're equal. So what is my square? Well, it's 2 times x minus 5/4 squared. That's why I put this number in a box. And then what do we have here? Well, we have 1 minus 25/8, or 8/8 minus, oh, where's my paper? 25/8. So what does that give us? It gives us a negative 17/8. Look, that's horrible, right? But this is what we have. And our y, don't forget, is greater than or equal to that. Now we've completed the square. We've got it in a way that we can say, what is our vertex? Well, our vertex is 5/4 and negative 17/8. It's gross, okay? It's just plain, I'm not even going to be able to make it look pretty. It's just not going to look nice, all right? This graph is just going to be hideous. But using this equation, let's find at least a couple more points to help us out. So we got our x and our y. And what do we have here? Here's my vertex point, right? My x vertex part. And we want to go on either side of it to try to find something here that will work. Well, to one side is 0. So let's see what that gives us. 0 minus 5/4, okay, is going to be a negative 5/4. Negative 5/4 squared is going to give us 25/16. Let's reduce because we have our 2 here, right? 2 goes here. This becomes an 8. So now we have 25/8 minus 17/8. And what does that give us? Oh, I'm almost off the screen, sorry. 25/8 minus 17/8 gives me 8/8, or 1. Now, there's no magic that's going to help me get this equal to a nice number again. What I want to try to do is have this still be equal to somehow 5/4, right? So what can I put here that if I subtract 5/4, I still have 5/4? Well, it has to be 10/4, right? 10/4, or you can reduce it to 5 halves, but I'm trying to stay with the fourths since we're doing subtraction here. 10/4 minus 5/4 gives me 5/4. So all of this is still the same. So my answer still comes out to be 1. All right? It's not a magic way. It's kind of still messy because 10/4 or 5 halves is going to not be clean to try to graph, right? So let's try to put this on a graph. So let's see here. I'm going to just kind of start my graph in the middle. And I'm not going to change the way these are valued, but let's try and make this work. 5/4 is the same as about 1 1/4. And negative 17/8 is about the same as negative 2 1/8, right? So positive 1 1/4, negative 2 1/8 puts us like right here. And then I have 0, 1, which is nice. So we can put that one there. But then I have this 10/4 or 5/2, which is really 2 1/2 and a 1. So 1, 2 1/2 and a 1. And then I can put in my parabola. Best I can do. Now I want to take a quick look at problem 23. It is 16, which is less than or equal to x squared, plus y squared, which is less than or equal to 25. We haven't done these in a long time. They didn't reference this at all in any of the practice exercises or models, but this is a formula for a circle, right? So we've got a circle that has a diameter, or sorry, a radius of 4 and a radius of 25. Two circles inside of each other, and our shaded part was going to be the spot in between 4 and 5, right? All around the circle. But we didn't discuss circles and doing this, and so I'm not going to go over all about circles again to try to go through this. If they want us to learn circles again, we'll learn circles again, but not right now. So on the next page, page 33, so I've crossed out 24, 25, 26, 27. These are all the weird ones that don't have a y, and we've got to find like we got to graph it like there is a y, but then take it away and bleh. All right, so we're not doing those. Cross them out, and then that also means that you do not have to do number 9 on your self-test, okay? Because that's the same. Well, this one's a circle. And like I said, we didn't go over circles, so you do not need to do number 9. And that's it for the video for today. I know a lot of this was review, but it was also probably new-ish because we haven't done completing the square in a while. But I know you know it, so we just got to bring it out of you. Bring it out of that deep core memory, right? And some of these things were new, but for the most part, it was still in review mode. Do your best. If you have questions, let me know. Otherwise, until next time.